Hello, dear students. Welcome back to my YouTube channel. As you all know that in this session we will start the electromagnetic induction, that is EMI. Okay. So yesterday we completed magnetic effect of current and the magnetism part. Today we will start the EMI. Okay. So if you want the notes of previous lectures, you can do one thing. You can just join my Telegram group. There you will find the lecture notes of magnetic effect, electrostatic, capacitor, current. These chapter notes you will find in my Telegram group. In the description part of this channel, okay, you will get my Telegram group's link. I guess I am audible and visible to all of you, right? No, but it is not specified. Now, look, you are telling me that when an iron rod is inserted in the coil, then it is no solenoid simply means we are having a material, simply a material, right? Inside the material, we are having different bases. Okay, different bases. Solenoid simply means that whenever we are having a coil, okay, a coil in the circular loop shaped, okay, that particular thing is known as solenoid. Inside this part we can insert different things, no? We can insert your iron rod or different non-conductive material also. It is also known as your solenoid, right? Am I audible and visible to all of you? Good vibes, Hassan and Tika beta. Am I audible and visible to you? Yes. Is there any lag? Because at my place I'm just facing a lot of network issue right now due to the weather condition. Okay, so I want you to be able to give me your response. I am lagging, right? Still, I'm lagging. This is a problem, no? This is a real issue. The real issue. So either look what we can do now. We will wait for a couple of minutes, right? If everything gets good, so we will start the EMI lecture. If it is stucking, right? If it is not going in a very smooth way. No, I'm lagging, na? हाँ, lag आ रहा है. I know it. I know it. I can just basically, na. What we can do, na? From my side, we can wait for a couple of minutes. If everything looks good, everything looks great and good, right? We can just start class. And if this thing continues, right, then we need to end the class because I am not comfortable with this network issue things, right? So this talking part, no, it won't help you, and you won't concentrate on the lecture. It feel a bored thing, right? You will feel after a couple of minutes you don't have any kind of an intention a good na regarding my classes because there won't be any kind of face things going on, right? Okay. So until then, na, you can ask me your doubts. I will just ask you. I will just give you a response. Na? If you are having any query or anything like that, you can just ask me. You can ask me your doubts. Na? No worries. I want to check my connectivity, but this internet issue is continuous, right? This is the continuation. The weather is too bad. Na? Weather is too bad at my place. One second. I need to check my connectivities again. We will wait until 10:45, okay? Or 10:50, we can just wait. No, we cannot extend this timing, right? Because if we extend the timing, you will lose your precious time. In this, if, let's say we don't have any class, so you can do one thing. You can just recap your previous sessions. You can do your homework, DPPs, module, right, in this particular time. So I won't take your much time. I will try to fix the network, right? Give me a time, so I will just try to fix it. Mhm. Give me some time. I will just try to fix it. I guess now my network is good. You just need to just let me know. Mm-hmm. Okay, right. So yes, right. But we don't have any guarantee, right, regarding the network things. So we will just start the class as soon as possible. Okay. So let's start now. But don't worry about it, no. Don't worry about the people who are watching the lecture, right? Yesterday, I guess you were not present in the session. Asana was not present. I guess you were also not present in yesterday's class, right? So these are not very big things for me, right? So I came here to teach, no. Look now. Today we will start EMI. So due to the reboot of the system, I got disconnected. So now I guess I am visible and audible, no? Am I audible and visible? Am I audible? Okay, now we are having some doubts. So one is I got engaged in black book, which book we should buy for JEE mains and advanced maths. So you can do the black book, no? Go to IE Erodo. So you are taking IE Erodo for JEE advanced, right? But that is not a good choice. Look now. So let us discuss the magnetic flux. Do you know what was the electric flux? That was the number of electric field lines crossing any particular surface area. That was electric flux. So magnetic flux is same as phi, and it just denotes that number of magnetic lines of force passing through any surface. any surface. Suppose I will take the same example that I take in electrostatics. If this is my any surface, and look, these particular lines represent your magnetic field lines. Done. This B. So you can see now my particular area is in this way, and my surface electric field lines are perpendicularly crossing it. So in this time, my flux will be maximum. Shambhavi Kumar, yes, beta, I know you, right? So I guess we have a lot of students in prayer sessions, no? So they're also watching these sessions, right? Okay. So basically, what is the technicalities behind taking any kind of area? All these things we discuss all these things in our back chapter, electrostatics. Here I will give some sort of guide, right? Okay. So now, if this is my magnetic field lines and my area is lying now in this way, you can see no any line is crossing this area. So what is flux? So flux is zero. Flux simply means from your area how many lines are crossing. So here maximum lines are crossing. The phi is maximum. Here no line is crossing. So phi is zero. So if somehow my flux is in this way now, if somehow we are writing that this is my flux, sorry, my area, sorry, my magnetic field B, and my area is placed in this way now. So what we can do, we will take a component form of it, theta. One component will be like this. If the area of this plane is A, so this will become now A sine theta. And this plane will become now this one now A cos theta. As we know that from this plane no flux will cross, from this plane maximum flux will pass. So phi came out to be magnetic field into A cos theta. A cos theta. So A is my area vector, B is my magnetic field. So phi came out to be, it is B dot A vector. This is my equation of magnetic flux. This is my equation of my magnetic flux. Okay. Let us talk more about magnetic flux. So I can write magnetic flux equals to B A cos theta, or flux came out to be, it is B dot A. Area means area vector. A is area vector. B is magnetic field. B is magnetic field. And this is flux. If we talk about it is unit, that is Weber. And it is a scalar quantity. It is a scalar quantity, right? Easy? Easy? You will find now maximum content. Na? You will find that, sir, we had done this part na? In previous lectures, just like this one. We completed this ditto thing from electrostatics. So it is a replica of that. Only there was electric field, here is a magnetic field. Ditto, right? Look now, same thing now. There we done two things. One was if my surface is 2D. One was if my surface is 3D. 3D simply means closed surface. 2D means open surface. Open means if we are having, let us suppose, any square. This is my square. Done. And area vector is always perpendicular to the surface. And my magnetic field is this one. Done. How to write my flux? Sir, flux is here BA cos theta. What is theta? Theta is the angle between B and A. But this one is also theta. This one is also theta. Which one you will take? Smaller one. So I guess theta is the smaller one, this one. Tick. If we talk about 3D, if this is my cylinder, right? So we are having one area vector here, one area vector here, one area vector here. That means area vector, it should be perpendicular and outwards. It should be perpendicular to your surface and outward to your surface. Yes, beta. Look now, if we are talking about JEE, look now, take my word seriously. if let us suppose you are talking about magnetism, but inside magnetism you will find numerical in which current and electricity is involved, in which capacitor is involved, in which electrostatic is involved. You will find in this particular chapter EMI current is involved. Maximum thing from previous chapters are involved. So it is not a importance of a single chapter. It is a combination of things, right? So you will find a numerical in which you can use a multiple concept things. Then only for you will get your answer. So don't think about now. I need to get this one. I need to get that one. No, don't think about it. So what is phi now? We know that phi is BA cos theta. If we are having it is for single term. If we are having n number of terms, so I will write NBA cos theta. What is n? N is number of terms. Number of terms. Let's suppose we are talking about one single sheet, no? One. So you can write n is 1. We are having a solenoid. Okay. Let's suppose n is 25 here. Congrats, beta. Okay. So let us talk about, sir, which angle I need to take my numericals. Okay. I'm just giving you the to the point information, no? To the point information. Look now. Suppose we are having a case. Suppose we are having a case. And this is my circular coil. Done. And look, this line represents axis. And this line is perpendicular to it. And we know this line is area vector. This one is बेटा कोचिंग कोई भी सी ले ना पढ़ना आपको है राइट हर कोचिंग में अच्छा ही पढ़ाते हैं सो दिस इज माय मैग्नेटिक फील्ड and my question is given axis of coil makes an angle of 30 degree with the field. So axis of coil, it is axis of coil. This axis makes 30 degree with the field. So this is my 30 degree. If somebody will ask you, beta, what is phi here? So you will write, sir, it is BA cos theta. B is B, A is A. What is cos theta? You will write 30. 30 is incorrect answer. Why? Because theta is the angle between B and A. This is 30. This one will be 60. So my theta answer is cos 60 degree. This one is correct. This one is appropriate and this one is correct one. By taking angles. Okay. Whenever you are dealing with these type of numericals, now think about from where my angle is given to me, right? Be very active in this kind of matter. So let us suppose we are having a numerical. Okay, we are having a numerical. Am I going too fast? Am I going too fast? Huh? Theta is the angle between the area vector, which is always perpendicular to your plane, and the magnetic field B. Okay, great, beta. We are having a numerical where my magnetic field B is given as 0.3 J cap Tesla. Where area is given as 2 I cap plus 5 J cap minus 3 K cap meter. Done. I need to get my flux. So I guess flux is equals to, it is B dot A only. So what is B? It is 0.3 J cap dot A. What is A? It is 2 I cap plus 5 J cap minus 3 K cap. This one is dot product. So in dot product, I into J is 0. Okay. So I need to do J into J. Is it 0.3 into 5? Is it 1.5 Weber? So my answer is 1.5 Weber. Okay. So we will just complete these things in a very good way, right? Because this is same as electrostatics. So I will not waste my time in explaining how I into J is 0, how J into K is 0, how J into I is 0. We know it from the vectors, right? 5 into 2.3. No, it is 5 into 0.3. It's 0.3. Daksh, right? Okay. You are from the Allen, I guess, right? From Kota, if I am not wrong. Okay, one more numerical. One more numerical is like, if my B as it is 4I cap minus K cap Tesla, and my area is given as 0.1 meter square. Clear? And this thing lies in XY plane. XY plane. So this is my X, this is my Y. My area vector will be perpendicular to it. That means K cap, no? So I guess I need to put here K cap. So find flux. Is it B dot A? Yes, sir. B is 4I cap plus K cap dot, it is 0.1 K cap. So what is my answer now? Is it 0.1 Weber? Is it 0.1 Weber? No worries, no worries. Done? Any confusion now? So these numericals are related to the open surface. Open means 2D surfaces. Let us suppose we are having a 3D one. 3D. 3D. Okay? 3D. If it is a cube with side A, now my flux is crossing like this. So we know that the flux is 0. Phi net is 0. How, sir? Look. This side area vector would be like this. This side area vector is like this. Area vector is like this. Area vector is like this, right? Look here. Theta is 90. Here theta is 90. Here theta is 90. Here theta is 90. Is 180. Here is 0 degree. Right here. So B equals to, sorry, it is not B, phi, right? So I can write phi. So phi equals to BA cos theta. I can write phi in. It is incoming now. That is BA. What is cos? It is cos 180, and cos 180 is minus 1. I can write minus BA only. This one is phi out. Phi out is BA cos 0 degree. Cos 0 is 1. That is, it is out is plus BA. Here theta is 90 degrees, so you can write cos 90 is 0. So this side no flux, no flux, no flux, no flux. So what is phi net? Phi net is phi incoming plus phi outgoing. Incoming is minus BA, outgoing is plus BA, so phi net came out to be 0. So if we are talking about the closed surfaces, so every time flux will be 0. If we are talking about the electric flux as well as the magnetic flux, in both the cases it will be 0 shunya. Am I lagging? Am I lagging once again? Yes, somehow my network is not stable. No, I guess there is no lag. No, there was a flux, the kind of not flux, the lag, right? Now there is no flux now, the lag now. Hello, beta. Okay, okay. So one more numerical. I guess you are getting my points, right? Navin Kirtan, yes, beta. You are from my previous classes, no? Yes, I do. So let us suppose we are having a solenoid. I will write the whole language. A solenoid, it is 4 centimeter in diameter. 4 centimeter. Yes. In this case, now look, in this case, flux is uniform, no? It is uniform in this case. If it were non-uniform, no? So there will be a B should be a function of something. Look here, no? B is only B. That it is constant, no? Where it is uniform. Okay. Solenoid 4 centimeter in diameter and 20 centimeter in length. In length has 250 turns and carries off 15 ampere current. Calculate the flux through the surface of a disc of 10 centimeter radius. Disc of, am I lagging? 1 second now. Now network is down. I can see it now. Network is down. I don't know why. Every time now it happens with me only, right? It's only with my classes. What to do now? Huh? Yeah, I know it better. I know it, right? I can feel it now. My video is lagging. I can feel it. Or what we can do right now? Hmm? I guess the day is not a good one, right? So today, every time, it happens with me, right? Every time. So basically, before my magnetic field, current chapter, every day we need to check these things, right? On a regular basis. I can feel it now. Your time is very precious now at this particular moment, right? So yeah, that is good now. That is a good suggestion from your end. Okay, so we can do one thing. We can do one thing now. This Sunday we can just take a class, extra class, right, for 2 hours or 3 hours. No, no, you don't need to sleep now. You're having your DBPs, your module, all these things. So you can do that things, right? So we can do one thing now. I guess lagging is increasing, right? So we can do one thing. Instead of this time, we will schedule one class for Sunday also. But in morning times, right? Before 11 o'clock, we will just have a session. So I guess that is good, no? It sounds good, right? Sunday morning, we will have a class. Is this good? Okay. I guess you can support me now on this particular thing, right? Sunday, right? Morning, no tension at all of sleep, very energetic, with full of zest, right? Yeah, tomorrow is also my class. No? Tomorrow, same, every day, same timing, you will have my class. Every day, same time, same time. Because our motto is to complete the whole syllabus before 15th of September. Coming September. Just mark my words. Before 15th of September, I will try to complete the whole syllabus of 12th. Then I had to start the 11th for NEET class or JEE classes. Okay. And before December also, I will complete that whole thing. Then in Jan, or I will do the recap or revision sessions. Okay. So I will just make you very good in physics now before your examination. If the examination is NEET JEE or your examination is boards one, right? We will do a 2 revision before that. We will do 2 revisions before that. And before examination also, we will do one revision class. Where is the important topics, important formulas, everything I will be providing you. Now, don't worry about anything. Do one thing, just trust on me, right? Ping me a message my Telegram and have a discussion with me if you're having any different kind of problems with your studies. So we can have a discussion on it. Don't worry about it. Anytime you can just reach out to me. Anytime. Or if you don't find anything, no, you can just do one thing. Just comment below your issue. Then I will just next class I will just discuss your issues. Okay, tomorrow is Raksha Bandhan, na? But Raksha Bandhan is in day, na? Our classes are scheduled at 10:30 night. Okay, Daksh, I am from Kashmir. Okay, I guess maximum students know me, right? Because we are from the same batch. They know me personally, right? Yeah, I am available anywhere, right? If you want me, I am available. YouTube, Facebook, Insta, every on every social media. Na, I am just available. My Telegram name is Shakur Sir Physics. You can do one thing. Go to the channel description bar. There you will find my Telegram link. Just go there, right? I guess we are more energetic now, but network is not giving us any chance to connect, right? So we can do one thing before 15 September. Mark my words. We will complete the whole syllabus. Don't worry about anything. We are having now. Look now. This chapter will take 6 or 7 days. AC will take 4 to 5 days. EM will take 2 days. Then we are having modern physics for 1 week. Then we are having semiconductor for 2 3 days. Then we are having optics for 10 days. That's all. Okay. So I just need to take a leave from your end. Thank you, Beta. Thank you for your support. Thank you. Bye. Bye. Good night. Have a good day. Night. Not a good day, right? Good night. Right. Have a good night. Bye.